Hello everyone. So for part 3 of your video lesson for this topic momentum, we're going to look at the applications of impulse. So that means how impulse is used in daily life. So these are the learning objectives for this video lesson. You need to be able to explain in terms of impulse and momentum, how impact force can be reduced for safety, how the knowledge of impulse can be used in order for us to safely reduce the impact force, and how impulse can be used to explain this thing called the follow through action and can give you an advantage in sports. Hopefully, you still remember what impulse is and the formula for impulse, and you can see from this formula of impulse it contains three variables, which is the force, the time variable, okay, and also delta p, which stands for the change in momentum. So because the three of these are connected together somehow through this equation, if you change one, let's say you change the force, you will change another variable. So if you change the force, you will also change the change in momentum. If you increase the time, you can also cause the change in momentum to increase as well. Or if you want the change in momentum to stay the same, you can increase the time, but you decrease the force. So that way, the change in momentum will be the same. So as you can see, these variables affect each other and there are uses for this, and you will see that in this video lesson. These are the application or uses of impulse in daily life. The idea of impulse is being used in cushioning impact. So for example, like in airbags, it is being used in follow through action in sports. For example, when you are swinging your golf club, and it is being used when the boxers are riding the punch, as you can see here. So we'll explain this one by one in this video lesson. Right, so let's first talk about airbags and how impulse and momentum can be used in order to help you stay safe. The point of airbags is to reduce the impact force when you have an accident and when you are trying to hit something. And it does that by increasing the time of collision between you and an object. It's slowing down the time so that the force of impact can decrease as well. If you are hitting something quickly with a large force, it will produce a large impulse. So the large impulse can be quite damaging to your body. So what can you do with this large impulse is that you increase the time it takes for your body to hit the object, for your body to stop. And then what that does, it decreases the force. So let's use the impulse equation to explain this. This is the impulse equation. And in during this process, when you're about to hit something, about to be in an accident, your change in momentum is the same. Okay, so this stays constant because your change in motion is the same, right? So you are going for in a situation where you are moving in a very fast velocity and you are being stopped. If you want to be safe, that change of momentum needs to occur in a extended period of time, right? If that change of momentum occurs in a very short period of time, in other words, you change your momentum in an instant, that's going to have a large impulse and therefore that's going to do a lot of damage to your body. So the change in momentum is constant in this case. You cannot change that whatsoever, but what you can change is the time. So if you increase the amount of time it takes for your body to stop, what that's going to do is it's going to decrease the force. All right. So, in other words, if this number increases and this number has to stay the same, what's that's going to happen is the number that is the force will have to decrease in order for the change in momentum to stay the same. Let's do example 3 to show how this works mathematically. You may pause the video and read the example, and then once are ready, you can play the video again, and then I'll show you how we can work through this example. Okay, so first you need the equation for impulse, and then the change in momentum here is equal to the final momentum minus the initial momentum. And we want to find the force in this case, so let's rearrange this formula to make F the subject of the formula. Now let's put in some values. The value for time in this case is 0.50. The initial momentum, we can get this from example 2, and this is equal to 8,000 kilograms meter per second. So this is the momentum just before the car hits the wall. What's the final momentum of the car? The car will be brought to a stop. So when it is stopping, that means that the car has zero momentum because it's not moving at all. So it will be a zero here. So calculating those, you will get minus 8,000 over 0.50, and that is equal to 16,000 Newton. Okay, if you compare this force with the force in example 3, you will see that the force in example 3 is bigger. The force in example 2 is bigger. That's because the time is less. Okay, it takes a less time for the car to hit the wall, and so it will produce a large force. But for example 3, you will see we have now increased the time to 0.50 seconds. Quite quick, but the time is much more longer. And even though it increased by a bit, the force has decreased by a lot. Okay, so we have shown here mathematically how the impulse equation and how increasing the time can decrease the force. The second use for impulse in daily life is something that is what we call the follow-through action. You see this normally in sports. Let's, for example, when someone is trying to swing their tennis racket, what they will do is that they will follow through their action. So instead of stopping once they hit the ball, they will follow through once they hit the ball, right? Same thing goes with soccer. They don't just stop as they hit the ball, they will swing their foot forward further than that. Same thing as in golf and as in baseball. Why do they do this? They do this because this will cause the ball to move faster. Okay, and if it's move faster, then they will have an advantage when it comes to the sport. So let's try and explain this using our impulse equation. All right. So when this happens, their force is the same, right? The force doesn't change. Okay, they swing just as hard. It's just a matter of if they follow through with their action, what they are doing is that they are increasing the time of contact between their tennis racket and the ball, or their foot and the ball, or the hand with the ball. So whatever it is. So they're just increasing the time of contact. So if you increase the time of contact, you are increasing the time. What does that do in this equation? That will cause the value here, which is the change in momentum, to increase as well. So, and it's beginning to move with a larger momentum. Okay, so it's becoming faster, right? So increasing the time will increase the impulse, okay, and also increase the change in momentum. And because the change in momentum increases, it causes a higher velocity. So the ball is faster. Let's do example 4 to see what happens in terms of the momentum when a ball is being hit and it changes direction. So the question reads, a baseball of mass 0.5 kilograms traveling horizontally at 37.5 meters per second east collides with a baseball bat. The collision lasts for 0.0012 seconds. Immediately after the collision, the baseball travels horizontally at 49.5 meters per second west. So what's happening is that you have a baseball, it moves to the east, which is to the right, And then you have this baseball. Let me draw it here. It's a badly drawn baseball. It moves to the east at 37.5 meters square. Then hit by the ball and it moves to the west at a speed of 49 or at a velocity of 49.5 meters per second. Determine the momentum of the baseball just prior to being hit. So momentum is equal to mass times velocity, and the mass of the baseball is 0.15. The velocity is just before it's being hit is 37.5, and you will get a momentum of 5.625 kilograms meter per second to the east. Okay, that is just before it's being hit. What is the average force applied by the bat to the baseball? So now we want to calculate force, and we know that force times by the time is equal to the change in momentum, right? Let's rearrange this formula to make force the subject. So change in momentum over time, and the change in momentum is basically the final momentum minus the initial momentum over time. And we can expand the formula even further over time. Okay, I ran out of space, so I'll put it at the top here. Mass is 0.15 times the final velocity, which is, now you can see there is a change in direction in this situation here. At first, it moves to the east, and then after that, it moves to the west. Because momentum is a vector, force is a vector, and velocity is a vector, you need to take into account direction when you are doing the calculations. So let's just take this east as the positive value, as a positive direction, and west as the negative direction. So we can use plus and minus to tell us about its direction. So negative is given to numbers that are moving in the opposite direction. So we are saying here in this case, west is the opposite direction. So now the velocity is minus 49.5. So that one, the whole thing minus the mass times the initial velocity. So the velocity at the start before it's being hit is 37.5. And the time is 0.0012. And when you calculate that, you will get minus 10,875 newtons. You might be wondering why does the force has a minus sign? That is because the bat is hitting in the west direction. Okay, it's hitting to the opposite direction. That's why it has a negative value, and that is the correct value. Let's do example 5. For this one, I'll let you read it first. So pause the video, read the example, and then when you are ready, play the video. To answer A, we need the same formula again. Force times time gives you the change in momentum. And we can expand this whole formula here, and we will get change in momentum is the final momentum, which is this term here, and this one here, this will give us the initial momentum. And we can move m to the other side, and we are left with this equation. Okay, remember we are trying to find the final velocity here. Now we can put in the values. So force is equal to 420 times time 0.0045 over the mass 57 grams, but then we change the mass to kilogram because everything needs to be in SI units. So that is divided by 57 divided by 1000, just in case you don't know how to change to kilograms. So that is 0.057 kilogram. The final velocity is what we want to find, and then the initial velocity is at rest, so it's at 0. Okay, so all you have to do is calculate everything on the left side, and what you will get is about 33.2 meters per second. And then B, repeat the calculation assuming a time interval of 0.053 seconds. For B, we're going to repeat the same thing again as A, but this time we have a time interval of 0.0053. So this is the formula from question A that we will reuse. Force is 420. Time is the one that's changed now. It's slightly longer. So this is the value that is being changed divided by the mass, which is 0.057, and that's equal to the final velocity, right? The initial velocity, this one here is 0, so we don't have to put it here in here. So you calculate that, you will get a final velocity of 39.1 meters per second. All right, so A, our final velocity is 33.2 seconds. B, when the time is slightly longer, we have a higher velocity, which is 39.1 meters per second. So C, explain the meaning and advantage of follow-through in this example. The answer to that question is the follow-through increase the time the force is in contact with the object, and therefore increases the change in momentum. So not just momentum, it increases the change in momentum, and this will cause the velocity to increase. Okay, so increasing the time increases the velocity, and that's why athletes usually follow through when they are doing their kicks, their swings, and so on. The last application for impulse is for boxers, and what they usually do is they ride the punch. Let's say they are punched, but they don't move their head, it will hurt. So what boxers are advised to do is they are advised to ride the punch. That means as they are being punched, they follow the movement of the punch with their head. So because the punch is moving backwards, their head is also moving backwards. And what that does is that will decrease the pain and decrease the damage because force is being decreased. So as you can see here is still the same sort of explanation as the cushion. So you're essentially cushioning the force. So you are increasing the time in order to decrease the force. And because the force is decreased, there is less pain. All right, to summarize, we looked at the application for the impulse equation, which is this one, and you can see there are three variables in the impulse equation. There's the force, there's the time, and also there's the change in momentum. And changing one variable can change the other variables, and that can be put into interesting uses and interesting application. We looked at cushioning and riding punches in boxing. So that's basically you wanting to increase the collision time. So increasing the collision time will decrease the force. And we also looked at another example, which is follow-through motion. This is for athletes doing baseball, tennis, and even football. This one is the opposite. You increase the time in order to increase the change in momentum, and therefore you will have higher velocity, a faster ball. And that is the end of this topic. I'll see you again next week.